Hello everyone. Today I'm excited to present our project Campus Navigator and Route Planner. This is a full stack web application designed to help users navigate complex campus environments efficiently. That is our LPO itself. The system can calculate the shortest routes, adapt to real-time traffic conditions, locate the nearest facilities such as ATMs or canteens, and even generate emergency evacuation routes. So the backbone of this project is a modern full stack setup. On the front end, we chose React 18 paired with Vite for lightning fast development and modular component structure. Tailwind CSS is what we use to keep interface sleek and responsive. For state management, we opted Zustand, which is a lightweight and easy to maintain the root data and app state. For the backend, we ran a Node.js and Express API that handles all routing requests and updates. What's unique is our SQLite database that is running behind the memory through WebAssembly. So there is no extra setup is needed. And for the final routing, the algorithms that we use are both implemented in JavaScript for the web and C++ for a standalone console version, ensuring we have both real-time web responses and having high performance narrative execution. And for the data structures, Dijkstra's algorithm and BFS are the two main algorithms that we use here to keep to complete this project successfully. So let's get into the working of the project. So this is one of the interface where we could see the campus map, a prototype map that I made for myself for explaining this project for now. Here we could choose a certain destination which we wanted to go at a certain time. So now since yeah. um, so now this is going to be a certain let's keep it at a little more distance. Yeah. So now this is the distance where I need to travel from CC block to main canteen. And here the Dijkstra's algorithm comes in role to find the shortest distance between these two particular block by reducing the time. Let's say on a certain day, the connection between library to CSC block is having more congestion. Like there are more people traveling on that area, which makes it more hard to pass by. At that time, in this admin panel, let's just say path between library to CSC block is having a lot of congestion. So we are going to keep the congestion block to the maximum thing severe. So this is how we have the congestion block. So now if we try to select the building again from CAC block to main canteen. Yeah. So since the congestion level between these two has become very high, which means there is a lot of crowd over there for a particular time, this would be the second shortest path to reach main canteen on a minimal time. So this is how that particular option makes this project to work. And here we get the output to lead this is the output that is going to lead the way to the user. And here's the walk time, which is calculated not only just by computing the distance that is given here and the amount of average speed that a user walks, that the people's average walking speed that has been fed inside to calculate this average approximate walking time for this particular distance. So let's come to the admin panel where we could do a lot of things. So just now, I just gave you a real-time example explaining the road status and traffic. And these three are places where we could add new places and new buildings. For example, cyber security. Let's say this is the place where our cybersecurity students are learned. So this is the place where I need to give my coordinates to exactly locate my building in the area. So we could also give a place where this building has an emergency exit or not. If it has, we could obviously give it a mark. If we don't have, we are going to remove it. And latitude, longitude are optional. If you want to keep your building precise or accurate, that is the time this latitude and longitude comes in for. So once I add the building, we could see the cybersecurity block just in the map. And let's give some routing. And to give the routes are given through this fourth panel, um, where let's say skip up. Yeah. So this is going to be a first route for cybersecurity block to MBA block. Let's say the distance between these two buildings are 450 meters. So there we go. The, the new block got its own route to MBA block, which is 450 meters. And this block can also be managed and deleted over here. So this panel is straightly for deleting the blocks if we don't need it. So once this is done, we could see here the entire block with its route is completely gone. To conclude, the Campus Navigator demonstrate how graph algorithm can be applied to solve real-world navigation problems. By combining Dijkstra's algorithm and breadth-first search with an emergency evacuation routing system with a modern full-stack architecture, we built a solution that is both practical and scalable. This project also helped us strengthen our understanding of data structure, algorithms, full-stack web development, and system design. Thank you for your time. I hope you enjoyed the demonstration.